Hello again, everyone. Welcome to the AP Computer Science A 2018 FRQ review. In this video, we're going to be talking about problem number 1, the hopping frog. So first, we can start off with the rules. This question involves reasoning about a simulation of a frog hopping in a straight line. The frog attempts to hop to a goal within a specified number of hops. The simulation is encapsulated in the following frog simulation class. You'll write 2 of the methods in this class. So I just went through and highlighted a key phrase, which is the frog attempts to hop to a goal within a specified number of hops. And that's pretty important because it does tell you how the frog simulation class is actually being constructed. As you can see here, there's a distance that's being passed in, and that's the distance to the goal. And there's a num hops being passed in, which is the max hops. So you see here, the frog attempts to hop to the goal within a specified amount of hops. So before we start with part A, actually, let's go through and just kind of look at what we have here. We have the public class. We have some class variables here, which is goal distance and max hops. We also have this function right here, private int hop distance, where the implementation is not shown. If you go to my GitHub though, you will see an implementation. Like I said in the intro video, I just implemented everything just for the sake of being able to test it. But here, the implementation is not shown. We can just assume that it does what it says it does, which is returns an integer representing the distance in inches to be moved when the frog hops. We also have this part right here, the public boolean simulate, which we're going to implement in part A. And basically what it does is simulates a frog attempting to reach the goal. It returns true if this frog successfully reached or passed the goal, and false otherwise. And then we have part B, where it runs num simulations and returns the proportion of simulations in which the frog successfully reached or passed the goal. And we have a precondition here assuming that num is greater than 0. So pretty much it's a pretty standard class, nothing too complicated here. I guess all you'd have to know is some basic referencing, I guess, variables and stuff like that. Referencing variables and stuff like that. Nothing really too complicated. So let's go to problem A. Problem A, first, here's a little bit of a game plan, I guess. The big game plan that I'm going to repeat throughout all my videos, and I want to repeat it through all the questions that we're going to do, every single part. And the first thing is read the prompt completely. I know when you're on the test, it can be a little easy to just skim through the prompt, but trust me on this one, reading through the prompt completely is going to help you when it comes down to figuring out what it is you need to do and solidifying a game plan. Rather spend a couple of minutes actually reading and understanding the prompt than kind of trying to rush through and then ending up making a huge mistake. And this actually happened to me where I would just skim through, start rushing, writing code, and then like I would glance back up at the question, or I would glance back up at the prompt, and then I would see a keyword and I'd be like, oh man, if only I'd seen that, my whole program would be different. So I'd have to erase everything and restart. So really just take the time to read the prompt. And second, come up with a game plan. So write and think of some pseudocode. Pseudocode is basically like, pseudocode stands for fake code. It's basically just kind of like write out what you're planning to do. Also, write a first draft and a final, or just a final if you're a genius. I mean, I honestly couldn't do it in just one go. I needed to write a first draft. I don't know if they're going to give you paper during the test, but usually in this section, I hope you can see my mouse, but I'm kind of like circling the blank spaces of the question sheet here. I would just kind of like really small font, I would just like write out a little bit of what it is that I wanted to do. Let me close that there. So yeah, write it out, kind of like plan it out, and then when you actually write the final draft, so that you don't have to continuously like erase your final answer and stuff like that, you can just like write an answer nice and clean on the answer sheet to make it easy for the grader to grade. And of course, get full points. Like that's objective number 1 right there. We're trying our best to get full points here. And one huge piece of advice that I did not include here, but it helps me out like in general, even now in university, because we still have to write out our code for answers. When you write out your code, put enough space between the lines so that you are able to write in an extra line of code in between if you needed to. Because if you put your code really close together when you're writing it out as an answer, and then you just kind of you know, you make a mistake and you're like, oh, I need to add something. Well, now you'd have to erase everything up to that part because you really aren't able to just squeeze it in, or you could squeeze it in really weirdly. The point is just give yourself space. You should have enough space to do that. So that's another tip. Anyways, to start with problem A. We want to complete the method simulate below. You must use hop distance appropriately to receive full credit. So I kind of thought through some pseudocode and I was thinking, okay, well, if we want to simulate this frog, we want the frog to hop a certain amount of times, and then once the frog hops a certain amount of times, we want to see if in any of those times if it passed the goal or if it reached the goal. So in my pseudocode I wrote, first we should get the frog's position based on the distance it hops from hop distance. We can call the hop distance function, and according to this, it says here it's going to return an integer representing the distance. So every time we call hop distance, it's going to return some random integer. Second, we want to see if that position is at or past the goal's position. So every time we call hop distance, we want to see if it's at or if it's past the goal's position. So at or past. And we do that each time. And how many times can we call distance? Well, again, remember from here, there's a specified number of hops. So if we go to where the frog simulation class is being constructed, see how there's a num hops being passed in? And we set the max hops equal to that. So we want to call our hop distance function this amount of times. So that's kind of like the game plan that we have going on right now. It's going to be something pretty iterative, iterate and then check, iterate and then check. So this is the answer that I got. I started off by setting the frog's position to 0. The frog started at 0 position. Then I had a for loop that was iterating up until the number of max hops. Each time I went into the for loop, I would call hop distance and I would add it to the frog's position. So if hop distance returned 2, now the frog's position would be 2. If hop distance returned -4 after that, then it'd be 2 plus -4, which is going to be -2. So it's stuff like that. Frog position keeps a current position on the frog. And then I check if the frog position is greater than or equal to the goal distance, then we can just go ahead and return true. If we continue on and this is never true, if the frog position is never greater than or equal to the goal distance, we will come out of the for loop once it's done and we'll just end up returning false. So is this correct? Well, we can check it we can compare it to some of the tests. These are the examples that they gave in the FRQ. And so it says here, you know, and also, real quick note, I recommend you do a couple of tests. If you have enough time when you're doing the FRQ, go through and try to like test in some values with your code. Do that if you have time, but really it does help, and it does sometimes show you, oh, are you missing an edge case or something like that. So let's try it out with this one here. So basically, what this code is going to do is just basically add whatever hop distance is returning to frog position. So if we go through, we would have 5, and then we check is 5. Oh, I kind of skipped the part here. So 24 is the position of the goal, and it can go 5 times. The frog can hop 5 times, and 24 is its position. So as you can see, there are 5 numbers here. So now let's check. First, we would come in 5. Is 5 greater than or equal to 24? It's not. We'd continue on. 5 plus 7, that's 12. Oops, sorry about that. 5 plus 7 is 12, still not greater than. 12 minus 2 is 10, no. 10 plus 8, 18, no. And then on the last hop, 18 plus 6, 24. Is 24 greater than or equal to 24? It is, therefore it would be true. And we see that this code, in fact, does do that. So now let's move on to part B. Part B's of these FRQs, from what I've noticed, they usually require something from part A, but they're usually shorter and they're more straight to the point. So make sure they're not always shorter, but they're usually shorter, and that's what I've noticed. And usually they're just really straight to the point. A little story here, if you don't mind. There was this time, I think it was when I actually took the AP test, that for one of the part B's, I just wrote a huge amount of code. Like I remember filling the page, And then like later on the next year, I think, when the answers got released, and I saw the answer was literally one line of code. And I got so mad because I was like, what? How is that? How is it that, I just went through writing all this? I'm pretty sure I got it wrong. But it just comes to show that like sometimes you really just have to be aware, like, hey, maybe it's an answer from part A. So just keep looking for that. Anyways, part B. Write the run simulations method, which performs a given number of simulations and returns the proportion of simulations in which the frog successfully reached or passed the goal. For example, if the parameter passed to run simulations is 400, and 100 of the 400 simulate method calls return true, then the run simulations method should return 0.25. Complete method run simulations below. Assume that simulate works as specified regardless of what you wrote in part A. You must use simulate appropriately to receive full credit. So basically we're kind of doing some like proportion calculator thing, which is really not that hard. So in the pseudocode I came up with maybe we should run the simulation a num amount of times. And if the frog passed the simulation, let's add it to a counter. And then in the end, let's get a fraction by doing some simple division, probably get how many times the frog passed divided by num, this variable that's being passed in. So this was my answer. And first I had a variable that I called total true, and I set that equal to 0. Then I went through for int I equals 0 and I is less than num, so that means I'm iterating num times I plus plus. And basically I run the simulation each time. I check the simulation each time, and I say if this dot simulate, you don't necessarily need the this, I'm thinking, but I just like to keep it in there. But if this dot simulate is true, then we're going to increment total true plus plus. And then in the end, you want to return total true divided by num. I'm doing times 1.0 just to make sure that everything's converted to a double, because this is an int and num is being passed in as an int. Therefore, I know there would be, and oops, that's another problem. And the return type here is a double. So just to make sure that we don't have any issues with that, I multiplied everything by 1.0. And so, yeah, that's pretty much, that pretty much works. I don't know if there's anything more to explain with that, but I do think that that is in fact correct. So, yeah, that's pretty much it. Thanks for watching. If you have any questions or if my explanation could have been better or whatnot, please feel free to just message me in the comments. All the code is on GitHub, like I said, and up next I'm going to be talking about a little bit of self-promotion. I'm just using the same clip over and over for all my videos. You can view the description, the GitHub links, social media links, Amazon affiliate links. I have some study materials down there, so if you need some study materials, feel free to take them through the Amazon links. Feel free to purchase them there. I'd really appreciate it. And also, if you like this video, please feel free to like and subscribe. All that would also be really appreciated. So, yeah, that's pretty much the end of the video, and I hope that you guys do well on the test. I know you guys are going to do great. And yeah, thank you. Have a nice one. And good luck on the test. Bye.